Thank you very much. So I'm Jun Nakamura. Yes, I'm working in the MTI. It's originally in NYK line, master of the NYK line. So now seconded to the MTI. So I'm happy to speak with you in this conference. Yes, firstly, I will introduce our project first. So Mr. Nakagawa mentioned our program, MEGURI2040 programs. Our project is one of the MEGURI2040 programs. So our target is a fully autonomous. It's a demonstrated simulation fully autonomous function in coastal vessel, not deep sea vessel. For coastal vessels, operation is our target. So what is the DFAST project? So DFAST project is designing the future fully autonomous ship. So our target is demonstrated fully autonomous ship navigation function. So our consortium member is about 30 organizations in domestic and over 60 organizations, including the global partners. So it is not only the navigation equipment maker, so shipping company, shipyard, and insurance company also including in our consortium. So organization to the DFAST project. So project management office is carried out in NYK group. Then risk assessment, concept design, and integration and demonstration will be carried out. Then we developed each subsystems. Then next is the systems overview. So DFAST systems overview is onboard. We have the onboard system in autonomous function onboarded. So this is a container vessel Suzaku. Size is 749 gross tonnage. Then we have the telecommunication system with satellite and 4G communication, and land-based system also. This land-based system including the two blocks. It is intelligent display block and emergency response block. So intelligent display block is ships information collection, monitoring the analysis. It means, for example, weather condition, traffic situation. Also, we are collecting the information in this intelligent display block. And not only the navigation function, engine remote monitoring, control, and abnormality detection also carried out intelligent display block. Then we have the emergency response block. This is remote operation function. So normally we carried out for collision avoidance by automatically. But in case system give up to the collision avoidance, so shore captain take over to the command from the remote operation center. Then captain making to the collision avoidance route from the shore, then sending to the vessel. So I will explain to the our subsystems. So DFAST systems composition is we have the 5 composition. One is maneuvering. It is for the navigation system. Second is the propulsion, including to the main engine, generator, boiler. Then next is the communication and centralized information management system and fleet operation system. So little bit unique is the centralized information management system. This system is all collecting to the all subsystem data. Then this all subsystem is all well for the autonomous navigation. So collecting to that information, centralized information decide to the autonomous shipping operation or not. If in case one subsystem cannot carry out to the autonomous operation, so centralized information decided to the stop to the autonomous operation. So system status and definition, we set up to the 4 status. So one is a normal situation. Next is an active monitoring situation. Third is a remote fallback situation. Last is a independent fallback situation. So normal situation is so vessel is all well. So vessel carried out autonomously without any touching. So active monitoring is so we have the possibilities going down to the fallback situation. If suddenly going down to the fallback situation, captain cannot take over to the any command. That's why we have the when we get to the possibility for the going down to the fallback situation, we activate the active monitoring. Captain, shore captain, stand by to the emergency response block. Then we have the remote fallback. It is so captain fallback, shore captain fallback to the from shore side if system any trouble occurred. Then finally independent fallback. So system is running under the fallback operation by system on the vessel. Then in this time, so just a demonstration. So ship's captain also on board. At this time, if independent fallback occurred, ship's captain take over to command in our demonstration. So next is for the maneuvering function. So we set to the apex auto function. This is action planning and execution system auto. So this is we make to the fully autonomous ship framework. So gathering information analysis is carried out by machine. Planning approved carried out by machine, but supported from shore side. For example, long-term planning allocated at shore with approved by shore captain. And short-term planning is allocated on board machine is primary. Secondary is shore human and machine. This is for remote fallback. So execution is machine side. Yes, next is a task category and execute allocation. So situation awareness, we separate the two situation awareness for the long-term object and event detection and short-term object and event detection. It means long-term is for weather information, traffic situation, or like that. Short-term object and event detection is for the collision avoidance. So it means yes. Then next is the detection of the decision making. It's a long-term response event from shore side. So I already explained from the remote operation center. And the short-term response and event is by machine for collision avoidance. Sorry. Next is the system design and the development process. So we making to the concept design. So we make the conopus and we follow up to the MBSE method. MBSE method is model-based systems engineering. So we have the picture. So in a shipping company making to the concept of the operation, then requirement, behavior, verification and structure will be making. So as much as possible following up to the MBSE method in our development. So methodologically of the V process. So first step is so we making to the concept design. Then we carried out risk assessment. So we have the two risk assessment methods using. One is STPA, system theoretical process analysis. Second item is FMEA, failure mode and effect analysis. So concept design to the basic design, we carried out STPA. Then next basic design to the detailed design. So we carried out STPA and FMEA. Then we take out to the any risks. Then we check to the by simulator. Then as much as possible, so testing to the reduce the on after equipped on board. So this is risk assessment method. So we making the control structure, then checking to the any risks. Then we making to the bow-tie model for countermeasure study and risk formalization. So then, and we making to the safety constraint. So, final consequence is for the navigation matter. So, collision, grounding, so, and seaworthiness, lost seaworthiness, and lost objected as a vessel and inside to the no-go area. Before come to the consequence, we set up to the safety constraint. We get to the 9 items by following by the STPA and vital risk analysis. And with our master's experience also include set up to this safety constraint. Then we make into the system integration test by simulator also. Then we get the any risks by risk assessment and carried out to the simulation test for we use the normal sequences, 75 sequence we carried out, and abnormal sequence also 34 sequence carried out through voyage, 8 voyage we carried out by simulator. Then we check to our risk assessment is true, or if missing item or something, we confirm to this simulation test. So next is a demonstration. So our demonstration is a round trip is more than 400 nautical miles. So this is southbound of the Tokyo Bay. I would like to cut off to the operations. So blue mark is our owned vessel. Then other vessel is a red mark. So now covering to the collision dangerous area for owned vessel's route. So vessel need to avoid to the this situation. Now planner considering to the how to avoid that situation. So now just making to the new route for collision avoidance. So new route was generated by the collision avoidance function. So also this is actual monitor. So we have the camera also. So, but still blocking to the collision dangerous area. So, planner reconsidering to the new route. Yes, then actually, so Mr. Nakanaga already mentioned. So we completed our autonomous. We carried out autonomous operation. About 99.7% we carried out by autonomous operation inside to the system operation. So challenge and our future. Yeah. So yes. So first item is need to the establishment and evaluation and verification system. So end-to-end simulation, evaluation framework, and risk assessment method is very important. And development social infrastructure is also important for autonomous vessel. Then challenge to the rule compliance autonomous navigation system. So it means, so an important point is so understanding characteristic human and machine to achieve goal of the rule. So characteristic is a human and machines mean, so machine's strong point is so accuracy and parallelism, but negative point is reliability and flexibility. So human is just changing something. If situation is something, so machine, so 36 continuously monitoring is possible and simultaneously monitoring of multiple ship also possible. But negative matter, difficult to use inaccurate data, for example, sound or something, machine is very difficult to try to use to that information. So what is the goal and method is correct? So our goal is for the lookout matter, mass checking to the for situation of the risk of the collision. But method is sight, hearing, and any other. It's sorry. Sorry. So yeah. Then goal and method is completely separate. Considering is a very important. Yeah. Finally summary. So our project is succeed high-level autonomous navigation at congested water. And presently, we are basic technology development we already carried out. So next step toward to the social implementation. And finally, a practical use of the autonomous ship is our final target. Thank you very much for listening.
Thank you. I don't know if my microphone's on, but what we'll do is we'll hear Ipol speak, and then we'll have the Q&A with the two others. Alex at the end there, and hopefully we have a representative all the way from Japan online. So Ipol, why don't you crack on and do your piece?
I will do. Thank you, James. Fantastic.